Welcome to the Pro Guide Do-It-Yourself Home Improvement video series.
Well, Les, I hate to interrupt your rapture, but weren't we going to do home repairs this weekend?
Oh. Home repairs may not be your favorite thing to do over the weekend, but if you want your house in good order, you really have to learn something about them. Hey, I'm Les Sizik.
And I'm Avian Rogers. You know, home repairs really aren't that bad to do. In fact, for the most part, they're really easy. And here's some of the typical home repair projects you're going to learn today. We're getting ready to change our faucet here on this sink. And there are a lot of different reasons why you might want to change yours. It may be corroded or leaking, or you just want to change the style. Like for us, we want to put on this brass and porcelain antique model. When you're selecting a faucet, the thing you want to be sure of is that the hole patterns match up. Now these kinds of things are fairly standardized, and we know that we have the same type, so we're going to be fine in that department. So the first thing we want to do is we want to cut off the water down below. Okay, the first thing we want to do is we need to turn off the shutoff valves that supply water through our faucet. So we turn those off. Now, if for some reason you don't have shutoff valves under your sink, you'll have to go to the main shutoff valve, which is usually outside your house. Turn them all the way off. Okay, now these two lines, these two pipes are called the supply lines, and they bring the water up to the faucet. So we need to remove these, and I'm going to put this bowl under because we're going to get some water coming down here. We'll remove these using a crescent wrench. Now that we've disconnected our supply lines, we're ready to remove the faucet. And let me show you how that's done on our new faucet. Faucets are attached underneath the sink by these nuts, so we need to release the nuts underneath the faucet. Now sometimes these nuts will be difficult to remove, and by squirting up some penetrating oil, that will tend to loosen them. And then with the help of a basin wrench like this, we can get up from behind the sink and release these nuts, which is what we're going to do right now. I unscrewed the nuts from the bottom of the faucet, and then I disconnected the supply lines. So now we can just put the faucet out, put it aside. Okay. Now, before I actually drop our new faucet into place, I wanted to point out this stopper lever right here. Now this will connect to a mechanism below by way of a thumb screw so that we can control the stopper to the drain. Now, right here at the bottom of each nipple, I put a piece of non-adhesive Teflon tape so that when we attach our supply lines, they're going to be leak-proof. Okay, now if your new faucet doesn't have any kind of a gasket, you may want to put a bunch of plumber's putty along the bottom and then seat that faucet under on top of the plumber's putty. Okay, so now I'm going to go down underneath and reattach these nuts, and then I'll connect up the supply lines. Once the faucet is properly seated, then you can attach the supply lines. You just want to make sure that this brass washer goes back into place, so don't forget that. And that just seats right down in there. Then the nut comes down, tighten her down. You don't need to worry about Teflon tape here because of that washer. And we'll tighten that down. Then I'll do the other one, and we can open up our supply lines again.
Another handy home repair to know is how to take up a toilet. There are two reasons why you might want to do this. One, the toilet has developed a leak and you notice water seeping out here. You just have to take the bowl up, replace the seal, and put it back. Another reason is you might not like the look of it anymore and you want a different color or something. You want to remove the whole thing. At any rate, here's the procedure. First, turn the water off here at the supply line. Flush the toilet a couple of times to get all the water out of the tank and out of the bowl. And then with a sponge, get what little remains in the tank. You're ready to disconnect it. There are two wing nuts that hold it on, one on each side that bolts right through the tank itself. Now these may be a little corroded. You might want to put a little penetrating oil or something in there. Then disconnect the supply line itself then the tank is ready to be removed. Then we'll remove the final two connections that hold the toilet down to the floor. Those are the two nuts we'll find under these caps. Now these may be badly corroded. You might even have to hacksaw these off or grind them off. Try penetrating oil first. Then cut through the caulk that's right in here. The reason for cutting that is it'll probably hold the bowl down so you can't just pick it up. And once that's cut all the way around, the toilet should lift right up. Revealing the old seal. Make sure that you get the right type of wax seal for your toilet. As you can see, some come with an extension on it. These are used when the floor has been built up with tile or something. In our case, this is the correct one to use. We're also making sure that the seal is room temperature or warmer before we try to make our connection here. Now we're all set to tip it back over. I'm going to spread the wax seal, line the bowl up with the wall, and also get a dead level. Now I've accomplished that. Having done that, I want to retighten all these nuts, the nuts on each side, and then after the nuts are tight, I'm going to replace these caps. Now, before you replace the cap, fill it with plumber's putty. That keeps water from seeping down that hole and getting under the toilet and possibly into the floor. The next thing, we're ready to put the tank back on the bowl. Make sure the spud washer is in good condition, and if it's not, replace it. The spud washer goes right in this depression here. Now reconnect your supply line, turn on the water, and you about got this baby finished. The last thing to do is run a bead of caulk all the way around the base of the toilet. This makes a waterproof seal between the toilet and the floor, prevents water from getting in there and rotting the floor, and makes the toilet very stable. We're going to be working with some copper pipe. This would be necessary if a pipe is broken or you want to add a fixture somewhere in your house. Now there's two things you have to do. You have to cut the pipe to length, and then you have to solder it or sweat it together. Let's talk about cutting it first. It's done with a tube cutter like this one, and you put the tube cutter right on your mark, the exact length where you want it. And it has this little pressure that you put on right here, and it's simply rotated around the pipe, adding a little bit of pressure as you go. We should be about through. Famous last words. There we go. Then we need to deburr the inside of here. If you left that burr on, it would be very difficult to operate because the burr would hang up stuff that ran through there in the water, little bits of mineral and what have you. And it could also make for some pretty loud noises in your pipe. So that burr has to come out of there. Okay, having finished the burring, we use a little emery cloth and rough up the outside ends of everything we're going to put together. And we're going to make a T, and the inside of the T will be cleaned out with a wire brush. This is necessary to rough up the surface of the copper, get all the dirt off, and that'll make the solder stick real good after we use this flux. Flux is this paste that goes on all the surfaces that will be soldered, and the solder will flow and follow exactly where we've put this, and it'll stick together. It's amazing how this flux works. The solder will actually run uphill and defy gravity. And we'll put this together and get busy soldering it. When we're soldering here, we're going to put the tip of the inner flame right in the center of the fitting. This will heat all three joints equally at the same time. This takes a little bit of time. And we'll be able to tell the copper will start to turn color, and we're going to test it here with the tip of the solder. And the heat is correct, and the solder melts instantly. 1 inch right on one spot. And the flux draws the solder right through the entire joint. That's a perfect joint.
Another typical problem is a clogged drain. Now, the first approach you might want to take is to pour some liquid drain cleaner down your drain and let that do its trick. If that doesn't quite work, then you may need to go down to the trap and actually pull it off and clear it out. But another thing that may happen is you could drop a contact lens, an earring, or a ring down the drain, and it's going to go down the drain and land right at the bottom of your trap. And the way to get that out is take the trap off and clear it out. So just to show you how it works, I'm going to, on purpose, drop this ring down the drain. So we got to get that out of there by going down here. All sinks have traps, and sometimes they're referred to as a P trap or an S trap. And what they're designed to do is hold water right here in this crook to prevent sewer gases from escaping into the house. But it's also a place where clogs will tend to occur. Or if you dropped a contact lens, an earring, or a ring, something like that, this would be a good place to look to find it. So that if you need to ever take your trap off, first thing you want to do is put something underneath it to catch the water when it comes down. Then you release these nuts. Now sometimes you can often do it with your hand. If you can't, just get a wrench and release these. Okay. And then just pour this out. Aha, here is our ring. Okay, now when you need to put this back into position, make sure that you have a washer in place. Now oftentimes, if you have to take off the P-trap, you'll find that the washer is fairly deteriorated. So you want to go down to the plumbing store and get new washers for both ends.
Dealing with a clogged toilet bowl is a dirty job, but somebody's got to do it. Today it's my turn, but pay attention because tomorrow it might be your turn. Now this kind of a snake here is a real good instrument for drains and sinks and that sort of thing, but it doesn't work in a toilet bowl because it's going to ding up the porcelain inside there and leave scars. For minor toilet clogs, hold it there, this job you'll do just fine. You've seen this, everybody's seen one of these. What you do is put it in here and up and down a few times and it just burps out that clog if it's a minor clog. If you've got a major clog, you're going to have to go to a heavy-duty instrument which is specifically made. It's a snake just for toilets. What you do is put this padded section down here right in the bottom of the bowl and shove this handle down in there. Out comes the snake and you twirl it around, crank the handle, and that'll get it. Here's the way it works. Insert it right in there, get it started up there, and then just jam this. It goes all the way down. That gives you about 4 feet of snake down in there, and that'll go right through the drain in the floor. Crank it around like that, and believe me, that'll do the job. One of the great disappointments of any homeowner is finding out that there's a serious clog in the main drain system underneath the house. I'm talking about clogs that don't respond to the small snakes and the liquid drain cleaners that you use. Heavy-duty clogs. Well, they're caused by two things. One is a big object getting lodged in the drain pipe itself, or perhaps an accumulation of something that starts and slowly restricts the drain. These need heavy-duty equipment to clean out. I mean, heavy artillery. Check this out. See that cutter there? This is a hand-operated snake that will really put some power into your drain. Even heavier than that is this big electrically operated one. This will drive, look at this. Is that heavy-duty or what? That's a saw blade that will actually go through tree roots that might have crept into the drain system, and they'll really do a job. There are 3 ways to access these bad clogs. One is, if it's located near your toilet, you can actually take the toilet up. You saw that that wasn't that difficult a job, and the end of the snake will fit right down there, clean out that clog right there. Another way is to look around your house and find out where your access plug is. This will be attached to the end of a big pipe like this. Take the plug off, and it goes in there, and that will access the main drain system. If you've got a newer house, these will be easy to find and will access almost the entire drain system. Sometimes these clogs have to be accessed through the roof vent itself. You have to get up on the roof. It's a little tougher, but bingo, you can put this right down, and that will access your entire drain system also. When you flip this switch on and off and nothing happens, it probably means you need to replace this switch or repair it. If you're going to replace it, there's lots of things available. Look at here. This is the kind that's just like the one coming out of there. This is a three-way switch. This is used when the same light is switched on and off from 2 or more locations. Here's a switch designed specifically for aluminum wire. If you have aluminum wire in your house, you must use a switch that is rated COALR. Here's a fancy kind of a switch with a rocker panel on it. Here's a dimmer switch. This will also work in there. All of these will replace this switch here. This is another kind of dimmer switch, just has a conventional handle on it here. This is a little timer switch. Push it down here to this position, and the light will stay on for 5 or 10 minutes, whatever you preset it. Here's a switch that will turn the lights on and off 48 times during the day. Now we've determined that the light bulb's okay, so what we need to do is analyze what's wrong with this switch. First thing we do is back out these screws and take the cover plate off. Now we're going to have to be very careful because I may have live wires here. I don't know. I'm sure, though, that we can find out with the voltage tester. I'm going to place one probe on one connection, the other probe on the other, and yes, I'm lighting up here, so I know that I've got hot wires to the box itself. Now, in looking at the switch, it looks as though the connections are tight, so there's nothing wrong with those connections. Now I know that the switch is bad, and I'm going to have to replace it. But before I do anything further on this box, because I've got power in there, I'm going to go down to my circuit breakers, turn them off, and put a sign on the box saying, warning everybody to don't touch that circuit breaker while I'm working up here. Switches are hooked up a number of different ways. If you're replacing a three-way switch in your house, the general rule of thumb is put the new one in just the way the old one came out. Using conventional switches, there are 3 ways that they work. One way is with screws. For demonstration purposes, we are showing both the hot and neutral wires hooked to the switch. Here's the ground. You will only hook hot wires to the switch, never the neutral. The other way to do it is strip the wires, and instead of putting that little roll in them, they insert straight into the back of the switch and are gripped that way. The kind we're replacing here is a dimmer switch, and we're going to use wire nuts and hook these 2 special leads to the hot and the neutral wire coming out of the box. Now we're just going to twist these wire nuts on. It doesn't matter which lead goes to which wire because this is a conventional little switch, not a 3-way switch. Push all those wires back in there, making sure nothing gets crimped, and make sure that the wire nuts don't come loose. And we simply screw the switch back in just like we had it before. And we replace the cover plate, cut the power back on, and we're back in business. Another do-it-yourself triumph. We've decided to replace this light fixture here. I think we can get something that looks a little bit better. Before I started fooling around with this, I turned the power off at the circuit breaker. And now what we're going to do is drop this down and get ready to take this apart and put our new fixture in place. I've taken one wire nut off. We'll take the other one. That's got that. Now before I do anything else, I want to use the voltage tester and make sure I don't have any power here. And I don't. I'm dead as a doornail, so we're safe to work. Now, light fixtures use different sorts of connector plates up here. You see, the one we need to put up is different than the one that's in there. So the next thing I need to do is take that out of there. Okay, there's the new mounting plate in place of the old mounting plate. We're ready now to put in the new, beautiful fixture. Now, this fixture requires an extension rod that I've screwed into the mounting bracket. And now I'm going to just poke my wires right up inside there. And then we'll be ready to make our connection. Now we about got this thing buttoned up. I'm going to put the wire nuts on very carefully. I want those to have a good grip. And then push all these wires back up into the box. And then finally, this little beauty goes right up against the ceiling. One screw against the shaft there. Tighten it down. And another do-it-yourself triumph. Is this beautiful or what? Oh, it feels good to sit down after doing all that work today. Oh no. Just when I thought I had everything fixed, the lamp's out. Well, no problem. I just happen to have everything I need to fix it right here. I've unplugged it so we don't have any power in there. Got my new socket ready to go. To remove the old one, I'm going to press where it says press, and that snaps right off. And then I'm going to unscrew the two connectors and drop my wires off. Just like that. And the bottom of the socket is removed next. Take the old socket off, that just unscrews. And then my new socket comes right apart. And I replace that right on there. Now what you do is identify one of these wires coming through there will have a little tracer in it. That means that's the part, that's the wire that goes to the brass connection in here. The other one goes to the silver connection. What happens to these sockets every once in a while, there's a mechanical connection in there and it just wears out, and that's what happened to our old one. So what I'm going to do now is reconnect these. The one with the tracer will go to the brass wire, and I make a little loop like that. That just makes it easy to hook up. Back off your screws a little bit. Wrap it right around there and retighten.
And here's a common problem. It's a cracked tile, but it's no major tragedy. It's easy to fix. It's also easy to put off, but don't, because water can get into those cracks and cause damage underneath, and you want to avoid that. So I'm going to bash it out using this cold chisel. Now we're going to get some tile chips as we work, maybe spraying up, so I want to wear the safety goggles. Okay, so I'll just start bashing away. Okay. You want to be real careful not to hurt any of these neighboring tiles as you work. Okay, I'm really starting to get somewhere. Now I'm using a cold chisel here rather than a wood chisel because I would really damage that wood chisel. Alrighty, now we cleaned out the backing, and you want to inspect this backing, whether it's a subfloor on a floor or drywall on your walls, because sometimes there can be some kind of deterioration or rotting, and if there is, you're going to have to consider tearing back as many tiles as you need to so that you can replace that backing, because it's only going to get worse with time. Okay, so we've got some mastic left over from our tile job. So we're going to spread that out. Now this is moisture-resistant mastic. You can also use a moisture-resistant silicone adhesive. Now we want to spread that out. We're leaving about a ½ inch space between the edge of the tile so it doesn't ooze out too badly. Okay. Maybe get a little bit over here. Alrighty, then we take our fresh tile and drop it into position. I also wanted to say, if the backing is just wet, just let it dry out really well. Okay, so I mixed up some grout according to the manufacturer's instructions, and I'm just going to drop a dollop on there. Boy, that's really nice and creamy. And then I've got a squeegee. I'm going to run that squeegee over the tile so that I fill the crack entirely. Okay, then with my finger, I'm just going to run over these lines so that the grout goes completely into those lines. No cracks. Okay. Then with a sponge, I want to wipe off any excess grout. Alrighty. Now, in a very few minutes, there's going to be a foggy haze that sets up over these tiles, and I'll just wipe that away with the cloth. In about 3 or 4 days, I'll take the silicone sealer, run that over, and it's going to be nice and waterproof. Here's a simple project, but it's so important that it's crazy not to do it. And that's to fill any gaps or cracks around the tub, shower, along the floor where the two meet, or any other kinds of surfaces where water can get behind and cause damage. Also check around your fixtures and soap dishes. I just fixed a bathroom where there hadn't been any grout, and I pulled back the tile to see the kind of damage there was, and every single stud was completely rotten. Now that's an expensive thing to have to fix. So we're filling it with silicone caulk, and you want to make sure that your surfaces are dry and clean, so don't run a bead of caulk just after you've taken a shower. Now we've got some minor hairline cracks back in here, so I'm just going to run a nice little bead of caulk in here. Okay, and then I want to come back and smooth it out with my finger, and then I'll clean up the excess with a rag so that it looks nice.
You ever wonder why the toilet will stop running sometimes when you jiggle the handle? Let's take a look inside the tank, see if we can figure out why. As you can see, I've taken the back of the tank out so we can get a good view of what happens in here. Now when you flush the toilet, everything rushes out of here into the bowl, and it slowly refills through the supply line, up through the ball cock valve, and out into this little tube, and that fills the tank back up slowly. As the water level rises, the float also comes up, and when the water gets within 1.5 inches of the overflow tube, the float is at its full height and shuts the valve off here, if everything's working right. Now when you flush the toilet, the ball flapper stopper raises like this, and it rushes all the water out into the bowl, and that creates the flushing action. The most common problem of a running toilet is in the tank ball. In order to fix a leaky tank ball, take the top off the tank, look inside here, and maybe it's something as simple as the chain has been tangled, or if you've got the old-fashioned kind, it could be that the rod is hung up somewhere. It may be that simple. Also, take a look under here, and where the ball sits in the seat, might be a little debris in there which you can just clean off with your finger, and that'll fix it. If that doesn't work, you'll need to get a new tank ball. They're very easy to replace. Make sure you get the kind that fits your toilet and simply replace it. Another reason for running toilet could be in the float ball here. When you reach into the tank and pick up on the float ball and that shuts the water off, then you know the problem is right there and your valve in the ball cock is okay. In order to fix this, simply bend this tube down until the natural level of the water does shut the valve off and remains about 1.5 inches below the overflow tube here. Now, one problem could be that this ball has filled up with water and loses its buoyancy. In order to fix that, you can buy a replacement, simply screw it back on there, and that'll restore it to good working order. If adjusting the ball float has not stopped the toilet from running, the problem is probably right here in the ball cock valve itself. It's very easy to take apart, and there's simply 2 little parts in here that you can buy in the hardware store, your plumbing supplier. He'll give you a new O-ring and the new valve. Set them in there, screw it back together, and that's all there is to fixing that. If this does not do the trick, then you may have to replace the entire ball cock. Get a brand new one and put that in. Make sure, however, when you go to the store to get one that's exactly the same height as the one you're replacing, because these come in all different heights, and you could louse yourself up by getting the wrong kind.
There are a lot of different reasons why you might want to change your shower head. For one thing, it might be clogged up or it doesn't work for some reason. Or you may want to use an energy-efficient, low-flow shower head. Or how about one of these, a Swedish massage shower head like we're putting on. Now, I've already put masking tape around these fittings and the pipe so that when I use the wrenches, they're not going to scratch the chrome and cause it to corrode. To actually remove the shower head, you may want to take some locking pliers to hold on to the neck of the shower head so that as you turn the shower head itself, you're not actually turning it back in here. You want to just loosen it up right here at the threads. Now, if it's older plumbing, it may take a little bit more work, but this one comes off very easily. Okay, now we're going to want to replace this Teflon tape that's right here, this white stuff. So I'll pull this old stuff off so that we can put the new on. Okay, good. The first thing we need to do to attach a shower head is we want to seal up this joint by wrapping some Teflon tape in a clockwise direction, and it will prevent anything from leaking. Okay, then for the shower head, I just screw on this fitting. I just do it by hand first and get it as far as I can. And then I'll tighten it down with the wrench. Give it one more turn here. Okay. And then this just simply goes on like that, and that's to be hand tightened. And then we'll have to remove the masking tape and put this into place, and we're ready.
Leaky faucets are a real drag, but the good news is it only takes a few minutes to fix them. Now, ordinarily, you'd be fixing faucets in place on the sink, in which case you'd have to turn the water off before you started to do this. We brought a few down here to the workshop just to make it a little easier for us. Now, here's what you do to fix this kind. First, take it apart. That snaps right off. And then we have to remove the stem, in this case, in order to get at the washers. Now, you may get lucky and find it's just a little piece of sand in there that's causing the leak. Or you may have to replace the washers. And you see there's two in here. You see the black neoprene washer in the bottom of the seat. Then you see the clear plastic washer. It's right up here on the top. That fits right in there. When you replace washers, make sure that you replace all the washers you find in there. You can buy the little kits of washers in the hardware store or the plumbing supply store, and that'll give you everything you need. Now, you may, particularly in some of the older faucets, find that the seat itself, where that bottom black washer sits, has been roughed up over the years. What you want to do, get you a little reaming tool like this and clean out that seat and make it smooth again. Now, having replaced the washers, the only thing you need to do, put the stem back in, place the handle back in place like this, and your repair is complete. Here's another kind of bathroom faucet that uses O-rings as well as washers. To get to them, take this little cap off, back off the screw, and the handle comes right off. Take the nut off of the stem, and the stem retracts. There's the O-ring, and down below you can see the little washer. Replace those two, and your repair is complete. This is a typical single-handle kitchen faucet. You get to the O-rings that control here this way. Take this big nut off with your channel locks, and then simply pull the faucet right off, and that reveals the O-rings. You see them here? 1, 2, 3, 4. They just pull right off, snap your new ones back on, and start the reassembly process. Now, some of these kitchen faucets will have a ball assembly in it like this. This would need replacing in that kind of faucet. Ours just uses O-rings.
What you're seeing is a house as it appears to the eye of an infrared camera. See those vivid colors? They indicate warm spots, places where the heat is moving outward and therefore being lost. This front entryway is particularly bad. Not only is there a serious problem between the bottom of the door and the threshold, there are gaps all around between the door and the frame and between the frame and the wall. These windows, especially the one on the end there, are in desperate need of help if they're to hold any heat in the house at all. Look at this heat loser. There's a crack in the foundation here that will probably have to be stuffed with some kind of filler like fiberglass or sponge and then caulked to stop this energy leak.
Hi, I'm Kurt Burbick. Well, I guess all of these problems look like a lot of work, right? Well, it's really no sweat. What you're seeing here is a lot of holes and cracks in the building, and all you have to do is plug them with a process known as weatherization. And with the weatherization techniques we're going to show you in today's show, you can solve a lot of your energy problems almost as quickly as I can describe them.
Boy, look at the dips and the cracks in this thing. It's completely worn out. Let's check the gap under the door here. Now, we can see it if we take this chisel and stick it underneath. It goes almost in completely. So we're definitely going to need to replace the threshold. Now, it looks like it's wedged in position here. So if we take a saw and cut across the middle of it, then we can just pry it up in two places, and that should be pretty simple. Before I cut the threshold, I set the blade on my saw so I only cut through the threshold and not into the floor. Well, it looks like this is going to pop up real easily. Got this flat bar. This comes right up. What a mess. And this one comes right up. Just getting this last bit of debris out of here.
All right, here's a stock piece of oak threshold that you could buy at any lumber yard. And as you can see, removing this threshold takes a little bit of care. You want to make sure you don't chip out these trim pieces on either side when you're doing that.
All I need to do is measure the opening now to cut this threshold to length. Since we're not taking the doorstop off, I'll need to notch around on both sides. Now that we've cut and notched our threshold, we're just about ready to put it in. But before we do that, we want to make sure that we caulk between the threshold and the floor itself. This is going to seal up any air infiltration from getting in there. Now, you're probably familiar with caulking tubes like this that go in a caulking gun. There are cans of caulk now available under pressure that only require you to depress the end of the nozzle to release the caulking material. Okay, now I'm going to attach the threshold with some 8-penny finish nails. Finish nails don't have heads on them, so once they're in place, you won't be able to see the heads. Now, before I do that, I'm going to want to drill in 3 or 4 places along the threshold. Since the threshold is made out of oak, it's hard wood, and it could split by the nailing or it could bend the nails. So I've got my drill bit the size a little bit less than the shank of this nail. Now that I've got the nails in position, I take this nail set and drive the nails a little bit below the surface of the wood. Then I'll come back and fill those little holes with wood putty, stain the threshold, and put some finish on to protect it.
There are a couple of things to talk about with caulking. It's a gooey material intended to fill the cracks in the building to stop air infiltration and moisture infiltration. So when you're about to apply caulking to a crack in a building, check it to see that there's no moisture inside the wall, because that caulking, once it's set up, will trap the moisture in the wall. Now, after about 2 hours, you can paint it. So if you're planning a paint job in your house, it's really important to do a thorough caulking job before you do that paint job. And also, don't apply any caulk in temperatures below 40 degrees Fahrenheit. It's a really very durable material. It'll last up to 20 years without cracking. Some people will need a little practice to be able to draw a good even bead of caulk, but you'll be aided in this by drawing that bead continuously rather than in a stop and start fashion. Now, the caulk actually needs to get inside the crack, so if the bead that you have drawn is on the surface of the wall, you'll need to take a putty knife to smooth that out. Now, the trick here is that the caulking gun you're using, or the pressurized can that Avian's using, could be held at just such an angle so that when the caulk comes out the end of the tube, it's forced immediately into the crack as you draw the bead.
Hi, I'm almost done here.
Hi, so what you up to?
Well, you know how you and I were talking about setback the other day?
Right.
About turning the thermostat down at night and during the day when the house isn't occupied? Well, it sounded like a really good idea, but I wasn't sure I wanted to be messing around with the thermostat every time I turned around. But this one here is programmable.
Oh, that's great. Did you turn the electricity off?
I shut it off downstairs at the furnace.
Good. It's perfectly safe to work with these with the electricity on, because basically it's a low voltage wiring system. But just for your own peace of mind, it's not a bad idea to turn it off. Well, it looks like a pretty easy installation.
Yeah, it's really been a piece of cake. All I do is take the wires coming out of the wall, I pop the old one off, and the wires correspond by color to this mounting plate, and then I mount it on the wall by these screws right here. Then the actual thermostat goes on top of that, and a couple of screws that attach it to the mounting plate itself. And then this cover plate goes on top of the whole unit. So I program it once, and then I don't have to mess around with it 2 or 3 times a day just to save a few dollars.
Oh, that sounds like a great idea. And I'll bet you'll save a little money too.
Yeah, I think it'll be a lot more comfortable around here this winter too.
All right, here's a place where setback or adjustment will really pay off, and that's at your hot water heater.
Now, household hot water temperature needs are about 110 degrees. And what you'll find is most hot water heater thermostats are set up on high so that your hot water heater is having to really work too hard for what you need. So experiment a little bit and turn this down to normal and see if that doesn't do the job in terms of your tap temperature. Now, by the way, here's a place where you're going to get some immediate paybacks on this. Another thing you can do to save some money is to install an insulation blanket around your hot water heater like Avian's done. Now, this is a very inexpensive and very simple device to work with. It's just a piece of insulation wrapped in plastic. It gets taped around the hot water heater. A couple of safety points here. First of all, on a gas hot water heater, you want to make sure that the insulation blanket isn't too close to the floor so that the air that needs to feed the pilot light doesn't get cut off. Up at the top, we need to discuss another safety issue, and again, it's with gas hot water heaters. And you'll know yours is a gas hot water heater, by the way, if it has a duct like this one at the top. The issue here is that this duct gets very, very hot, so you want to be careful not to tape the insulation blanket too close to it. All right, now, since we have set the temperature down to 110 degrees, you may feel there's an appliance in your house that needs warmer water than that. So you can install this booster heater on the hot water pipe just in front of that appliance, so now that appliance will get the warm water that it needs. Just a little something else about energy efficiency then in terms of your furnace. If you will get it adjusted and tuned prior to the winter heating season, it'll be a real cheap way to save money on your heating bills. Now, you'll need a professional to help you with that, but the do-it-yourselfer can get involved here by checking the furnace ducts, and where you've got a joint in the duct that hot air may escape, you can take some duct tape, silverback duct tape, and tape those joints so you won't lose that hot air at these various points in your duct system. And again, you'll get a money payback on this one. In any given day, in any house, 40 to 50 pounds of moisture can travel up through the ceiling into the attic area. Moisture that comes from washers and dryers and people taking baths and showers. And if the attic isn't properly ventilated, that moisture can get trapped up there, causing a lot of deterioration in the insulation and the wood framing. And if insulation gets damp, it begins to lose its R value. So let's take a look at what we have to do in our attic to get it properly ventilated. We need to let the air start flowing into the roof out here at the roof overhang, up between the rafters, above the insulation we installed, and out the top. We need to let it out as high as possible. Down here in the flat gabled end of the roof, right here would be one place, or in the case of a hip roof where all the roof faces are sloped, up here at the peak. Now, no matter where you let it out at the top, it's important that you get good air circulation from all sides of the roof. It's also important that you check each rafter space to make sure that this airflow pattern isn't interrupted by any wood blocking. If you find that, just drill a couple of holes to let the air flow through. There are several low-cost and simple devices you can buy to install on your roof to achieve this airflow pattern we've been talking about. For instance, at the roof overhang, you can install this interesting-looking little device. It's called a soffit ventilation plug, and it's got louvers and screened to allow the air to flow through, but to keep out the insects and the rain. The way you install this is to drill a 2.5-inch diameter hole in every rafter space all around the roof overhang of your house. Once the holes are drilled, then you can just pop these little devices in place, and that'll now allow the air to start flowing in at the low end of the roof. Once it comes up to the peak, there's several ways we can let the air out up there. For example, here's a sheet metal, louvered and screened ventilation piece, which can be installed in the flat gabled end of the roof to let the air out up high. Or if you need to let the air out up at the peak, you can do that by installing this continuous ridge vent piece. It's screened and it's sheet metal to let the air flow out, but to keep the rain from coming in the attic area. Now, this comes in 10-foot lengths, and if you put them together end to end, that'll allow you to vent the entire ridge of your house. One more item I'd like to show you, and it's a real gem. That's this wind turbine ventilator. You install it in your roof, and the wind grabs these vanes and starts it spinning. That encourages the air and the moisture in your attic to get carried out through the roof. It does such a good job, in fact, that we can't resist installing one in our attic roof.
To install the wind turbine, the first thing we did is find a good location. Obviously, we want it as close to the top of the roof as possible, and to be sure that we clear the rafters below, as they act as our support for our whole roof system. Next, we drill a starter hole and complete the cutting of our opening using the reciprocating saw. Next, we'll take our caulking gun and apply a generous amount of roofing cement, taking all the necessary steps to ensure that our wind turbine is completely leak-proof. Since we don't have shingles here to contend with, we'll cover those aspects and other issues in our roofing show. Then we take the base, put it into position, and nail down using some roofing nails. Once that's installed, this fits neatly into place, attach it with screws, and we're all set.
All right, you can remember from our infrared thermograph what a big heat loser this foundation crack was. And even if you didn't have a special camera, you wouldn't have any trouble figuring that out. Look at the size of that opening. Now what I'm doing here is I'm just finishing up stuffing in this fiberglass insulation into the crack. By the way, don't use fiberglass without wearing your gloves. What you want to do is back up the caulking so you don't have to fill the whole crack with caulking. And that's what the fiberglass is. It's just a backing material. And you just stuff it in there and pack it in good and tight. All right, I'm just finishing up with the last little part of this bead down here at the bottom of the crack. And a trick you should remember when using a caulking gun is when you're done and you pull the gun away to release this trigger at the back so the pressure doesn't continue to drive the caulk out the end of the tube and cause a mess. All right, now that we've got this all sealed up, we're not going to lose any more heat here. We're all done with this one.
If we all followed Avian's example, and in addition to insulating our attic and roof spaces, we tightened up our home with a good weatherization program, we'd cut down or eliminate big heating bills. If you have a board that squeaks or is discolored or badly warped or chipped or damaged like this board here, you can cut that board out of the floor and replace it with a new one. Now, that's a fairly easy process to do. You can take a saw cut from one end of the board down the center of the damaged board to the other end. Then with a hammer and chisel and a flat bar, you can remove those pieces without damaging the wood on either side of that damaged board. Now, we'll do that with our electric power saw. And we need to set the depth of the saw blade cut so that it doesn't go any deeper than a fraction of an inch beyond the thickness of the board we're trying to remove. We do that by adjusting the table on this saw, which we've already done. What we're going to use here is what's called a plunge cut. That is to say, rather than pushing the saw straight through the wood to get it started, we hold the saw in this position where the table touches the floor up front here. The saw blade is tilted up in the air so the blade isn't touching the wood. Then we pull the guard back and we pull the trigger, and when the blade is spinning, we drop it gently, easing it into the wood without moving the saw either forward or backward. Once the blade has gotten into the wood and the table is flat on the floor, then we can start pushing the saw through the board to the other end, being careful not to push the saw too far so it doesn't damage the good board beyond this one, or starting too close to this good board at this end and thereby damaging that. Now, before you do this cut, of course, you must always remember to put on your safety goggles first. A little more work with this chisel, getting this wood out of here. Just work your way along the board. Then you can use the pry bar. Carefully measure and cut your board, and then with a saw, cut the tongue off the edge of the board so it'll fit into the slot better. And also chisel the tongue off the board that's in the floor, again to allow this board to fit better.
Then when your board is in there, you can glue it into place, and you can pre-drill and face nail this board down. So now when you sand your floor, you'll have a floor without a broken board in it.
You're probably familiar with walking across a wooden floor and hearing it creak and groan under your feet. Well, all that is a board that's loosened up due to natural expansion and contraction. And when you put your weight on it, it rubs against the nail and makes a noise, a lot like a cricket rubbing its legs together. We have this illustration up here to show you how a floor is constructed so that you might better understand how to repair these ills. These are called floor joists, and they support your entire floor system. Then on top of that is the subfloor, and then finally on top of that are your hardwood flooring planks. Now once you've located your squeaky boards, repairing them is a pretty simple matter. An easy solution is to pre-drill through your floor so that you can then nail into your floor, through the subfloor, and possibly into your joist. Now, this same method can work for warp boards if they're not too badly warped. If your floor system is on the first level, you can go downstairs to your basement and you may find that your floor joists are exposed, in which case you can screw up through your joist, your subfloor, and into your flooring and pull it down tight. Now, should you need more support than that, you might install some bridging between your joists. It's usually made up of a 2x4 or a 2x6, and that'll give you some more support to nail into. Now when you find boards that are rubbing up against each other, fill them with some graphite or some wood dough. Okay, with these solutions in mind, Kurt's going to show you some answers to another little problem.
Well, fixing a hole is really a pretty easy job. First, you clean out all the broken pieces around the edge like we've done here. Then you cut a piece of drywall just slightly larger than the hole, like this, and on the back side, carve away the gypsum, and you've made what you'd call a hat patch. And that fits in the hole like this. Now all we need is a little bit of mud. And it's patched.
This wall here is so damaged that it can't even support a patch. So we're going to have to create some support. Now you can use some steel mesh or old crumpled newspaper. Now don't forget, each layer should be completely dry before applying the next. And your final coat should be sanded smooth and flush to your wall surface before you paint.
For a sizable crack like this one, you'll need to take several steps and some time to fix it properly. Clean out this larger crack with the pointed end of your can opener blade so that it'll be clean and no loose material will be in there, and that'll make your patch job work better. Now that that's cleaned out, you can take some drywall compound and fill the crack. And when the crack is filled, take a piece of fiberglass tape and embed it in this mud. The fiberglass tape is to give strength to this patch job so that cracks don't reappear over time. Also, you can use fiberglass tape to patch all the many hairline cracks like this one that you'll find in plaster walls. And because it's got a sticky side to it, you can stick that right to the plaster surface, covering up those hairline cracks. Now, while this mud is still wet, apply a second layer on top of the tape and feather it out on each side of the tape so that the tape is completely covered up. And go back and get all the fiberglass tape on your hairline cracks in the wall. After this is dry, it should take 8 to 12 hours. Give it a light sanding, and then come back and give it a second layer of compound, just like you did the first one, where you feather it out on each side smooth with the wall. Do that on all the cracks in the wall. Then, after it's completely dry, you give it a light sanding, and if you have a smooth textured wall like ours, you'll be ready to paint. If there's a special texture on your wall, you'll need to add another layer just to imitate that texture before you paint.
A hole like this you can fill with some quick drying mud as a first coat. Force it in with a taping knife. Then once that's hard, then we can come back around with a finished coat of drywall mud.